All right, so today we're going to look at the first lesson in Unit 13, which is a review of the Pythagorean Theorem, special right triangles, trig functions, the reciprocals of trig functions, and special ratios or trig ratios of special angles, things that you'll be using in pre-calc next year. So let's start with a review of the Pythagorean Theorem. And as we're looking at any right triangle, the two sides that make up this right angle are called the legs. And then the side that is across from the right angle is the hypotenuse. And remember, it's always the longest side because it's across from the largest angle. And Pythagorean said that if you took the legs and squared them, so a squared plus b squared, it will always equal that hypotenuse squared. So we're going to go ahead and use that theorem here. Let me make these really big. And if you want to, go ahead and pause the video and try the theorem on your own because it is a review, or you can walk through it with me. It's your choice. But I'm going to start with this first one. And so because my legs are 4 and 8, I'm going to start with 4 squared plus 8 squared equals the hypotenuse x squared. So we have 16 plus 64 equals x squared. And I'm going to flip the x squared and I'm going to add the 16 to the 64. So x squared is equal to, and 16 plus 64 is 80. So to solve for x, we are going to have to take the square root of both sides. We're going to want the exact value of this radical, so we have to simplify it. I don't want the decimal answer. So we are going to prime factor 80. So we get 8 and 10. And you should recall that 8 is made up of 3 2's. And 10 is a 2 and a 5. So to simplify, I've got x equals the square root of, so I'm going to take 1, 2, 3, 4 2's, and the 5. So we still have that 5. So remember, because it's a square root, I want groups of 2. So I have one group of 2, which means that it is going to come out in front of the radical. So a 2 comes out in front. Then I have another group of 2's, and so that's going to come out in front of the radical and get multiplied to anything that's in front. And then anything that's left over under that radical that doesn't have anything to pair up will stay underneath the radical. So our x becomes 2 times 2 is 4, radical 5. All right, the second one is just a little bit more difficult only because you have one of the legs in the hypotenuse. So I'm going to take my legs and square them. 22 squared plus the x squared equals 24 squared. And 22 squared is 484. So I'm going to actually put the x squared first. Plus the 22 squared, 484, equals, and then 24 squared is 576. Then I'm going to subtract the 484 from both sides. So 574 minus the 484 is 92. So again, we're going to take the square root of both sides to solve for x. And we are going to have to prime factor 92 to simplify this radical. So I know that 2 goes into 92 46 times, and then 2 goes into 46 23 times, and 23 is prime. So at this point, my x is going to equal 2 2's and a 23. So we're going to pull out a pair of 2's out in front, and then the 23 will stay underneath. So x is equal to 2 square root of 23. Okay, so there's your review of Pythagoras Theorem. Then let's talk about special right triangles. So you should have learned how to deal with special right triangles of 45, 45, 90, and a 30, 60, 90. So what I like to do is a pattern. So your 45, 45, 90, and it all is based upon Pythagoras Theorem. But if this is 45 and this is 45, then the sides opposite those equal angles, they are also going to be equal. So if you want to know how these are derived, well, let's just say that this is 1 unit and this is 1 unit. So using Pythagoras Theorem, just like we did before, we can find this hypotenuse, and the hypotenuse ends up being the square root of 2. If you don't believe me, take 1, square it, and add 1 to it squared, and set it equal to x squared, and find your hypotenuse, just as we did in those other 2 examples. So for our pattern in a 45, 45, 90, each of your legs are going to have the value of 1 and 1, and the hypotenuse will have a value of 2. And this is important because let's look at 3 and 4. So I'm going to make these really, really big because I need a lot of room. You are not going to have quite as much room, so they're going to be really small in your paper, so try to fit it in as best as you can. But as soon as I see that this is 45, I know immediately that the other angle here is 45. The other thing I know is that the sides opposite those angles are also the same. So if they give me one leg is 10, I immediately know that the other leg is 10. So I already know that that leg is 10. Now you could use Pythagoras Theorem, 10 squared plus 10 squared equals y squared, to find this based upon this information, but I'm going to show you how the pattern works. So generally I take my angles, which are 45, 45, and 90. And then I'm going to use that pattern that we just came up with above. So across from 45 should be a value of 1, so we put the pattern first. So 45 is 1, 1, and radical 2. And I got that, remember, from this right here. So my leg, this leg here, let me move it over so you can see it. So this leg here, right, is across from the 45, so it has a value of 1. This leg here is across from the 1, and the hypotenuse is across from the rad 2, which is the 90 degrees. So that's where I got this pattern here. Anytime you have a 45, 45, 90, you're going to write the pattern 1, 1, rad 2. And what we're going to do is create 3 equal ratios. And below these, I'm going to put the actual values that we have in our problem here. They're going to go in these denominators. So I'm going to look at one of my 45s, and across from the 45 I have an actual value of 10. So 10 is going to go in this denominator. And then on this 45 I had an x, so you could put an x there, but I already know that these legs are going to be equal, so I'm going to put another 10 there. And finally, across from the 90, I have y. So then I'm going to put a y here. And then you're always going to have at least one of your ratios. You'll have the entire top and the bottom will be numbers. So you won't have any variables in there. So I can take either this one or this one, it doesn't matter, and set it equal to this fraction, which does have a variable in it. So I'm going to create a proportion. You can see right here, these two fractions equal a proportion, and I'm going to solve. So I'm going to do that probably down here. So I'm going to do 1 is to 10 as the square root of 2 is to y. And remember, to solve a proportion, we are going to cross multiply, right? So 1 times y is going to give us y equals, and then 10 times the square root of 2 is going to be 10 square root of 2. And so that is our value for y. So y is 10 square root of 2, and we already discovered what x was without having to do any math because these are the same. So the x is 10. So really what we have is 10, 10, 10 rad 2, which is in the pattern of 1, 1, 1 rad 2. They just all happen to be multiplied by 10. So they're multiples of 10. All right, so let's look at number 4. Number 4 is another 45, 45, 90 triangle. So I'm going to put the 45 here, and remember these legs are equal, so that means x and y are the same. So once you find x, you're going to know what y is. So let's go ahead and set up our ratios. So I know I have a 45, 45, 90 triangle. And so I'm going to set up my ratio 1, 1, rad 2. That's my pattern, always. And then below for the denominators, we're going to actually look at our problem and see what do we have across from 45, or across from the other 45, and across from the 90. So across from this 45, I have a y. So I'm going to put a y in. And then across from the other 45, I have an x. So I'm going to put the x in. And then across from the 90, I have 16. So in goes 16. Because I know that both x and y are going to be the same, I just have to choose one fraction to go with this full fraction here. This fraction doesn't have any variables in it, so I'm always going to use this one. And I think I'll use these two since they're right next to each other. So I'm going to do it down here. 1 is to x, as the square root of 2 is to 16. So we are going to cross multiply here. So I get x radical 2 equals, and then we're going to cross multiply here. 1 times 16 is 16. So then of course to solve for x, it's being multiplied by the square root of 2, so I need to undo that by division. So I need to divide by the square root of 2 and divide by the square root of 2. And then these are going to cancel, and then you would have x equals this. Now if you recall from algebra and then from what we did earlier in the year, you cannot have a radical in the denominator, so we're going to rationalize it. And to rationalize it, I need to multiply it by itself. Remember, a radical times itself gives you the number under the radical. So radical 2 times radical 2 is just going to be 2, because remember this 2 times 2 is 4, square root of 4 is 2. So radical 2 times radical 2 is 2. However, I have to multiply this fraction by a form of 1. So whatever I do to the denominator, I must do also to the numerator. This right here is a form of 1, so it does not change the value of this fraction, it just changes how it looks. So 16 times the square root of 2 is 16 square root of 2 divided by, as we said, rad 2 times rad 2 is just 2. And then the 16 and the 2 can reduce. So 2 goes into 2 once. And you can hear my Vishla whining because she hears me talking, so I apologize. 2 goes into 16 8 times. So we end up with x equaling 8 radical 2. So x is 8 radical 2, and y also has to be 8 radical 2. So that one was a little bit more involved. Let's look at one more 45, 45, 90 triangle. And you can try this one on your own if you want to. It's a little bit more difficult because the hypotenuse is 14 rad 2. So if you want to, you could start off with me helping you with the work, and then you can pause the video when you feel comfortable finishing the math on your own. But we have a 45, 45, 90. So the other 45 is here, right? And remember that the x and y are going to be equal because they're both my legs. And the pattern is going to be 1, 1 radical 2, always. And then all that's left is to see what goes in these denominators. So across from this 45 is a y. Across from the other 45 is an x. Now she's shaking herself in her crate. She's going to dig herself a nice little bed, so you're going to hear a bunch of noise. Sorry. Across from the 90 degree is 14 rad 2. And what's nice is you have a radical 2 and a radical 2 in the same fraction, which they can cancel. So if they cancel, remember there's nothing left up here in the numerator. There is a 1 left up here. So it's 1 over 14. 1 over 14. So 1 is to x as 1 is to 14. So I'm going to start with that ratio. 1 is to x as 1 is to 14 because I canceled out those radical 2's. And what's nice is when we cross multiply here, x times 1 is x. 1 times 14 is 14. So for our cross products, I get x is equal to 14. So this one's actually pretty simple. So if x is 14, y is 14. The only difficulty was this part right here, that if you notice that, you need to cancel it out. It makes your work so much easier. Okay, so let's talk about the 30, 60, 90 triangles. So the pattern for the 30, 60, 90, as we spoke about way up here. Oh, we didn't talk about that yet. Let's talk about it. So across from our 30, right here, we're going to put 1 again. But across from 60, the pattern is going to be the square root of 3. And across from the hypotenuse, the pattern is going to be 2. This is always the ratio for every 30, 60, 90. Always, always, always. So your short leg, which is across from the smallest angle, 30 degrees, is always going to be 1. That does not look like a 1, does it? Let's try that again, a 1. And then your longer leg, which is the 60 degrees, because that's the larger angle for the legs, is always radical 3. Your hypotenuse across from that 90 is always 2. So let's use those. That's just your only second pattern that you need to use. I just lost all of my numbers. Hold that thought. Okay. All of my calculations, I don't have to make them again. Okay, so let's look at this problem. So if this is 30 degrees, this angle here must be 60. And so immediately I'm going to set up 30, 60, 90. And I'm going to use the pattern we just talked about. 1 for 30, radical 3 for 60, and 2 for 90. And then just like we did with the 45, 45s, we're going to look to see what's across from each of these angles. So across from the 30 is x. Now in this triangle, the legs are not the same because the angle measures across from those legs are not the same. And then across from the 60 is y. And across from the 90 is 8. So we're going to need 2 proportions. But notice that our fraction that has both numbers in there, 2 8s, can be reduced. 2 can be divided into both 2 and 8. So 2 goes into 2 once, and 2 goes into 8 4 times. So we're going to use the fraction 1/4 with each of these. So I'm going to do the 1 is to x and 1 is to 4 first. So 1 is to x as 1 is to 4. We are going to cross multiply. So x times 1 is x, and 1 times 4 is 4. So x is equal to 4. Next, we're going to take radical 3 is to y as 1 is to 4. So radical 3 is to y as 1 is to 4. So again, you're always using that full ratio in both of your calculations if you have to do 2 different portions. So we are going to cross multiply and solve. So 1 times y is y, and 4 times the square root of 3 is 4 radical 3. So that was easy, no simplifying of radicals, nothing. And if you consider the pattern, 1 rad 3, originally 2, so 1 rad 3, 2, if I took 2 and multiplied it by 4, that's how I got the 8. If I took the 1 and multiplied it by 4, that's how I got 4 for x. And if I take the radical 3 and multiply it by 4, that's how I got the 4 rad 3. So these are just multiples of the original pattern. So let's look at something a little bit trickier. Number 7. So again, I see the 60 degrees. If this is 60, this has to be 30. Just remember, these acute angles here add up to 90 because all 3 angles add up to 180, and 90 is already used. So as soon as I see that 30, 60, 90, I'm going to write it out. I'm going to write the pattern below it. 1 rad 3 and 2. And then we're going to write across from each of the angles. So across from 30 is y. Across from 60 is 27. And across from 90 is x. So our only full ratio is this one right here. So I'm going to use this one with 2 is to x, and this one with 1 is to y. So let's start with the x. So we have the square root of 3 is to 27, as 2 is to x. So let's cross multiply. I'm going to do x times the square root of 3, and then 27 times 2, which is 54. So this one's going to create an issue. When we solve for x, we have to undo it being multiplied by 3. We have to undo it by division. So I'm going to divide by the square root of 3 and divide by the square root of 3. So x cannot equal 54 over the square root of 3 because remember, we have to rationalize any radical in the denominator. So to rationalize this radical, we have to multiply it by itself. What we do to the denominator, we have to do to the numerator because we have to multiply by that form of 1. So we end up getting 54 times the square root of 3 over 3, and then 3 cancels into 54. So 3 divides into 54 18 times. So x ends up being 18 square root of 3. So make sure you're rationalizing those denominators. And then we are going to do it again. But we're going to use the 1 is to y as a square root of 3 is to 27. So same thing. We're going to multiply, cross multiply, y times the square root of 3. So I get y square root of 3. And then 1 times 27, which is 27. And again, we're going to solve for y by dividing by the square root of 3, which puts that radical in the denominator. So I have to rationalize that denominator by multiplying top and bottom by rad 3 over rad 3. So I get 27 square root of 3 divided by 3. And of course, this 3 divides into the 27. 3 goes into 3 once, 3 goes into 27 9 times. So y ends up being 9 square root of 3. All right, last problem on this sheet and last problem for today. We'll do the second half tomorrow. So then for this one, I've got 60 degrees there, so 30 degrees is there. And that means I'm going to start off with my 30, 60, 90. And then my pattern, 1, rad 3, and 2. So learn your 2 patterns. Vishla is shaking herself. So sorry. Across from your 30 is 5 rad 6. And then across from 60 is just y. And then across from 90 is x. So again, our full ratio is this one right here. Don't worry about trying to rationalize this one. It'll work itself out. So I'm going to find x first. So I'm going to use 1 is to 5 rad 6 as 2 is to x. So we'll start off with that. And so we are going to cross multiply. So 1 times x is x. And then we're going to multiply these together. So I'm going to do it kind of slowly. 2 times 5 times radical 6. So 2 times 5 times the square root of 6. Because the 2 and the 5 are outside the radical, they can actually be multiplied together. So x ends up being 10 square root of 6. All right, so then we're going to use our second ratio. We'll do 1 is to 5 rad 6 as 3 is to rad 3 is to y. So 1, whoops, I don't want that color. So 1 is to 5 radical 6 as radical 3 is to y. So we are going to cross multiply. 1 times y is y. And then we are going to have 5 times rad 6 times rad 3. So we can only multiply what's outside of a radical to what's outside and what's inside to what's inside. So the 6 and the rad 3 get multiplied together. Instead of multiplying 6 times 3 and getting 18, I want to simplify that radical. So instead, I am going to tear apart the 6. So the 6 prime factored is 2 times 3, and then the other 3. So the 6 became 2 times 3, and then I brought down this 3. So now, remember, it's a square root, so I want pairs. So I can make a pair of 3 that comes out in front, and it has to get multiplied to that 5. So we really have y equals 5 times 3. Where I get the 3 from, this pair of 3's came out as 1 3, and it has to get multiplied to what's out in front. And then the 2 cannot pair up with anything, so it is left underneath the radical. And all that's left is for us to multiply the 5 to the 3. And so the y is 15 square root of 2. Okay, so on your homework, you are going to complete questions 1 through 6 only. Aren't you lucky? That is not very much. So 1 through 6 only. All right, ask me questions if you're struggling. Good luck.